Hello everyone, welcome to the lecture. This is the last section in Module 1 that we're going to talk about. It's section 1.6, where we look at some basic applications, and by applications I mean word problems that are going to involve whole numbers and operations on whole numbers. So the first problem here, first question, says a movie fan installed shelves for his collection of 400 DVDs. If 36 DVDs fit on each shelf, how many shelves did he need? Okay, so the individual has 400 DVDs total. Each shelf can hold 36 DVDs. So really, we want to see how many times 36 goes into 400, right, to figure out the number of shelves. So this is really, in disguise, it's a division problem. So if I divide 400 divided by 36. So remember last time we talked about how to do this division. We first asked, does 36 go into 4? No, it doesn't go into 4. So we move over. Does it go into 40? Yes, 36 goes into 40 once. So then I multiply 1 times 36. Gives me 36. I write it beneath. I subtract. So 40 minus 36 is going to be 4, right? Basically, I'm borrowing a 1, right? So this is going to be 4. And I bring down the next digit, 0. And how many times does 36 go into 40? Well, again, it goes in once. So I multiply. And now my remainder is 4. So the answer is going to be 11 with a remainder of 4. So basically what that means is that I would need 12 shelves, right? Because you want to make sure you have enough shelves to fit all the DVDs. If we only use 11, we wouldn't quite have enough. So I actually want to use 12 shelves. So that would be the answer. So 12 shelves. Okay, again, it was just a division problem. Okay, second question says a garden is rectangular in shape, and they tell you that it's 26 feet in length and 14 feet in width. If fencing costs $13 a foot, how much will it cost to enclose the entire garden with fencing? Okay, so for a problem like this, you definitely want to draw a picture. Okay, so let's draw our garden. It's a rectangle. We're told that the length, I'll call it L, is 26 feet. And we know the width, I'll call it W, is 14 feet. Which means this side must also be 26, right, feet. And the side opposite, the other one is the width, that's also 14 feet. Okay, so first thing I need to do here is I need to figure out the total amount of fencing that I need, right, to enclose the garden. Well, that's simply going to be the perimeter. So I want the perimeter. I want to find the perimeter first. Because that would be the total amount of fencing that I need to enclose the garden. So how do I find the perimeter? Well, remember, that is simply adding up the lengths of every side, right? So this is going to be 26 plus 14 plus 26 plus 14. So if you add these all up, if I just do the ones place, I have 6 plus 4 plus 6 plus 4, that's 20. So I'll write down the 0, carry the 2. Then 2 plus 2 plus 1 is 5, plus 2 is 7, plus 1 is 8. So it looks like it's going to be 80 feet. So the perimeter, call it P here, is 80 feet. Okay, now the that's a good start, right? We definitely needed the perimeter to answer this question ultimately. But what they really want to know is how much it will cost, right, to enclose the garden. So we look at the additional information that we're given, and we're told that the fencing costs $13 a foot. And we know that we need 80 feet, right? The perimeter is 80 feet. So if I multiply, you can see the units here. If I do $13 per 1 foot, and I multiply by 80 feet, the units of feet will cancel, right? Feet over feet cancels, and I end up with dollars, which is exactly what I want. By the way, we're going to spend a lot more time talking about conversions later on in the course. But for now, intuitively, think of it as you want to multiply your cost per foot times the total number of feet, right, for the perimeter, and that should give you the total amount of money it's going to cost. So let me do this on the side over here. I have 80 times 13, right? So 3 times 0 is 0. 3 times 8 is 24. Write a 0 here. 1 times 0 is 0. 1 times 8 is 8. Then I add. So it looks like that this is going to cost $1,040. So that would be the total cost to enclose the garden with those dimensions. Okay, let's try another problem that looks at applications that specifically deal with multiplication. So there's several little small problems within this one large problem. So the first one says, Sarah hiked uphill for 7 hours. Each hour, her elevation increased by 90 meters. So it increased by 90 meters per hour. Compute her change in elevation in meters relative to her starting point. Okay, so again, this is going to be a multiplication, right? You could think of it as her elevation is increasing by 90 meters per 1 hour. Let me go back to the regular size here. Okay, that's better. So 90 meters per 1 hour times 7 hours. Right, she's hiking for 7 hours. So again, we will learn a lot more about conversions, but the units of hours, if I have hours over hours, that cancels. And I'm going to end up with meters, right? So I just have to multiply 90 times 7. So 90 times 7. Well, 7 times 0 is 0. 7 times 9 is 63. So this is going to be 630 meters. And they wanted to know, the first part of the question says, write a symbolic expression using multiplication that represents this problem. All you had to do was write 90 times 7. Or you could write 7 times 90, right? It means exactly the same thing. Okay, second question says, a baby gained 2 ounces per month for 9 months. Find the baby's total change in weight relative to her original weight. So again, we're given a rate here, right? 2 ounces per 1 month. And it's increasing at that rate for 9 months. So if I multiply by 9 months, that should give me the correct answer, right? Again, the units of months will cancel. And now I have 2 times 9, which is 18 ounces. So this should be 18 ounces. And the actual expression here is simply going to be 2 times 9. Right? We multiply 2 times 9. Okay, and the third question, it says Leslie bought coffee 6 days this month and charged it to her checking account. She spent $3 each time she visited the store. Determine the total amount spent. Okay, so again, we can think of this as she spent $3 per day times, and then she did this for 6 days, right? So it's times 6 days. The units of days will cancel, and I'll end up with the amount of money in dollars, right? So I'll end up with dollars, so this is going to be $18. So the expression is simply 3 times 6, and the final result is $18. And then the fourth one says, Tally bought 30 packages of hot dog buns for her fair booth. Each package contained 9 buns. Okay. How many hot dog buns is this in total? Well, again, we can think of this as this rate is really 9 buns per 1 package. And I'm multiplying by 30 packages. So units of package cancel. And if I multiply that, that's got to be the total number of buns, right? So I need to do 30 times 9. That's going to be my answer for this part, right? 9 times 30 or 30 times 9. And if I do this out, this is what? This is 0 and then 27. So it looks like 270 hot dog buns. Okay, and let's look at one more example of applications. And in this case, all these applications are going to involve division, okay? So the first question says, together 5 friends have $35. If they share the money equally, how much does each friend get? Write a symbolic expression using division that represents this problem. Well, if 5 friends all together have $35, right? If we divide 5 into 35, or the same way as saying 35 divided by 5, that must tell us how much each friend will get, right? If it's divided evenly. So really this is going to be 35 divided by 5. Okay, you can write it out in terms of units. It's $35 divided by 5 friends. And this, of course, is going to equal $7 per one friend, right? So it'll be $7. Each person will have $7. Okay, second question says, George bikes to school each day. If he can travel 27 miles in 9 hours, how fast does he travel in 1 hour? So really what we're looking for is the speed, right? The distance per 1 hour, like how fast, right? Think of it as miles per hour, right? When you're driving your car, the speed is in miles per hour. It's exactly the same thing here. So really to solve this, I'm just going to have to divide again, right? It'll be 27 divided by 9, which you can write like this too, right, with a slash. So this will be 27, let me write it with the units, miles divided by 9 hours. And if you work this out, this turns out to be what? I guess it's 3, right? Miles per hour. So this is simply going to be 3 miles per hour. So the units of miles over hours is also sometimes called mph, right? Miles per hour. All right, the third question says the temperature in Scottsdale increased by 4 degrees in 4 days. If the temperature changed by the same amount each day, what was the change in temperature per day? So they basically want like an average temperature per day. So if it's 4 degrees over 4 days, right, I want to divide. So really this is just 4 divided by 4. I can simplify that, and of course it's going to be 1 degree per day, right? Per 1 day, I can just write day. So this is just 1 degree per day. Okay, and then the last question says Yvonne bought a total of 660 t-shirts. If there were 6 t-shirts per package, how many packages did Yvonne buy? Okay, so again, if I divide, right, if I take the total number of t-shirts, 660, and divide it by the number of t-shirts per package, that's going to give me exactly how many packages there are, okay? This also works out in units, although we haven't really talked about dividing fractions yet, but let me just write this out. So if I have 660 t-shirts, and I divide by 6 t-shirts per one package, it turns out that when you divide this out, you're going to get your answer in packages, the number of packages. The number of t-shirts, those units will cancel, okay? We'll talk more about that when we talk about dividing fractions. So, but in this case, it's intuitive, right? 660 divided by 6. So let's do that out. So 660 divided by 6. So 6 goes into 6 once, right? So I subtract at 0, bring down the next digit, which is 6. 6 goes into 6 once. Subtract, bring down the next digit, which is 0. And then we have to say 6 goes into 0 0 times, right? We have to put that 0 in there. So this is going to be 110 packages. Okay, great. So that should help you with the MyOpen Math problems for this section. Again, they're just word problems or applications that involve whole numbers. Thanks.